All right, let's do some chain rule. So we got product rule, which you use when two things are being multiplied. Quotient rule, which you use when two things are being divided. And then chain rule is when you have a composite function. So you have a function inside of a function. So it's going to look a little messy when I first write this, but as I go through and explain how to do it, it'll make a lot more sense, I think. So this is like if I have y equals f of g of x. This is not f times g. That would be f of x times g of x. This is you have a function inside of another function. So for example, if I have ln of 4x squared, this would be your f, like your outside main function. This would be your g, or what I'll call your little guy. That is the inside function that is something is being done to it by the outside function. So they're not being multiplied, it's one kind of inside of the other. If you have that, the derivative goes like this. You take the derivative of the outside, of the main outside dominant function, and you leave the little guy alone, you leave the inside alone, and then you multiply by the derivative of the inside. So if I were doing this problem, what I would do is I would take the derivative of the outside. So natural log, the derivative of natural log is 1 over typically x. But in this problem, there's not an x inside of it. There's a 4x squared inside of it. So the natural log of blah, the derivative of that is 1 over blah. You think of it that way. Then you need to multiply by the derivative of the little guy, or of the inside, or in this case of the 4x squared, so you'd multiply by 8x. And just to complete this problem, this would be like 8x over 4x squared, which would reduce to 2 over x. But that problem is not my main concern. My main concern is the main point. Let me show a different way to do this. I'm just going to do examples to get through. And this is the way I typically go through it and explain it. So let's say I had, cosine of 4x squared minus 1. You got a big guy and a little guy. You got your f and your g. Your main outside dominant function, which is cos, and then your little guy, which is kind of inside of that, and that's 4x squared. What I want you to do is call the little guy u. We're going to do what's like a u substitution thing here. Then I want you to take the derivative of that little guy. So du represents the derivative of u. And the derivative of 4x squared minus 1 is 8x. Now I'm going to rewrite the original problem and say, okay, that's not cosine of 4x squared anymore. That's cosine of u. And that's okay, since u represents 4x squared minus 1, I can put it in place of it. I'm going to take the derivative of this problem. So the derivative of cos is negative sine. But what you have to do, and this is the chain rule part of it, is you have to multiply by du. So that is like multiplying by your g prime. That's like multiplying by the derivative of the little guy. You have a u that you took the derivative of. You need to multiply by the derivative of that u. You might be saying, well, why didn't we do this before? We kind of did. We technically did. You just didn't have to worry about it, because what du is in this case is just 1. So then I would take the derivative. It'd be negative sine of u times du, but since du is 1, it doesn't make a difference. I'm not done. Going back over to here. Sorry for kind of bouncing back and forth here. I'm going to plug in u and du now. So u is 4x squared minus 1. Du is 8x. And that's your answer. And you have done the same thing we did at the top. We took the derivative of the big guy, so the derivative of cos is negative sine. We left the little guy alone, our 4x squared minus 1 stayed the same. And then we multiply by the derivative of the little guy. This u du thing just kind of puts it in a better, I think it helps you organize it a lot. I think it's going to help you when problems get harder. So that's what I'm going to emphasize. If I went over to finish this problem here, I would do the same thing. Plug back in what we used to have. So u is x and du is 1. So if you're thinking, well, why didn't we have to do this before? We didn't, because du was always 1, so it didn't matter. All right, let's say y equals 4x squared minus 3x to the negative third. So my big guy, my outside function, my dominant function is this negative third power. And the stuff in here is the little guy. So I'm always going to set u equal to my little guy. Then I'm always going to find du. So the derivative of my little guy is 8x minus 3. Then I'm going to rewrite the original problem with u in its place instead of the 4x squared minus 3x or whatever the case might be. Then I'm going to take the derivative of this. So the derivative is bring down the power, reduce the power by 1, and if you take the derivative of a u, you got to multiply by du. Now I just plug in this in place of u and this in place of du. So y prime will be negative 3 times 4x squared minus 3x to the negative fourth times 8x minus 3. Typically, the way they write these answers, they don't want negative exponents. So the next thing I'd want you to do to simplify is to get rid of negative exponents. So this is fine, but anything with a negative exponent, the way we get rid of negative exponents is to flip to the bottom. So rewriting this would lead me to that answer. All I did was take the negative exponent and put it to the bottom, and then this would be your answer. Right. Let me go through one more, and then we'll be practicing this for a couple days, and then combining this with product rule, chain, and quotient and chain all together, and they can get pretty complicated. Hopefully today's isn't too bad though. Let's say I had the square root of x to the third minus 4. So first I would just rewrite it so there's not a radical sign there because it's a lot easier to work with powers. And then I would go over here and say, okay, this is my big guy, outside dominant function. This is my little guy. So I'm going to set u equal to the little guy. I'm going to find du. So the derivative of that is 3x squared. Then I'm going to rewrite the original problem with u in place of whatever I put it in place of. So this is really just u to the 1/2 now. Take the derivative here, but you took the derivative of a u, so multiply by du. Plug back in. And then one more thing is getting rid of negative. You're done with the calculus part, really. But getting rid of negative exponents does matter, so we're going to do that too. So this 1/2 splits. That kind of identifies your top and your bottom. This is a positive exponent, so it's going to go on top. This has a negative, so it's going to go on the bottom and then become positive. All right, so hopefully that's not too bad. Try the problems tonight, and we will get after it some more tomorrow.